Brain's novelty dial, linked to early dementia signs, scientists have pinpointed a specific brain mechanism, a gradient of neural activity, that governs how we process new versus familiar environments. This discovery sheds light on why disorientation is often an early indicator of neurodegenerative diseases like Alzheimer's, and could help in earlier diagnosis. How the brain maps familiarity. The study, published in Nature Communications, used brain scans and virtual reality to observe how the brain responds to exploration. Researchers found that the hippocampus, a key region for memory and navigation, contains a dial of activity. One end of the hippocampus reacts strongly to places we've been before, while the other fires up when we encounter something new. This isn't just about remembering landmarks. The hippocampus isn't simply a map. It's a system that distinguishes between known and unknown, from broad city layouts to precise locations like where you keep your keys. The gradient between these areas allows the brain to transition between broad spatial awareness and detailed recall. Novelty versus memory. A gradient approach. Previous studies showed inconsistent results regarding novelty processing in the hippocampus. This study resolves some of that confusion by demonstrating that the response isn't localized, but rather a gradient. The brain doesn't simply have a novelty center or a familiarity center, it has a spectrum. The cortex, the brain's higher thinking hub, also displays a similar gradient. Central regions prefer familiarity, while outer areas prioritize novelty. This organization helps the brain adapt by focusing on new details when exploring, then integrating them into established memory systems for future navigation. Why this matters for dementia. The brain areas responsible for this novelty familiarity gradient are among the first to be affected by Alzheimer's disease. Both ends of the hippocampal spectrum are equally vulnerable in early stages, meaning disorientation and getting lost are often the first noticeable symptoms. Episodic memory, the recollection of specific events, is also closely tied to this navigation system. Because episodic memory is also early affected by Alzheimer's, the gradient mechanism can help explain why disorientation is so common in early cases. If you wanted to enhance people's ability to be independent, you'd want them to be able to go to new places and understand new things, says Zita Padai, a cognitive neuroscientist. Understanding how the brain encodes spatial novelty could lead to measurable biomarkers for early dementia detection. This research underscores the fundamental link between navigation, memory, and cognitive decline.